Hi everyone, let's get started with today's lesson, quadratic functions. In general, the general form of a quadratic function is a function in the form of ax squared plus bx plus c, where a, b, and c are constant and a is not equal to 0. The shape of the graph of a quadratic function is a parabola which is symmetrical about the axis that passes through the turning point, that is minimum point or maximum point, and it depends on the value of a, the coefficient of x squared. Now let us analyze how does the changes in a, b, and c affect the shape and the position of the graph. The first case, where the value of a changes only. Change in the value of a affect the shape and the width of the graph. However, y-intercept remain unchanged. When a is greater than 0, the shape of the graph is a smiling curve which passes through the minimum point. This is shown by the graph on the left side. A is greater than 0, meaning a positive value. And we can see the axis of symmetry passes through the minimum point. When a is less than 0, the shape of the graph is a crying curve which passes through the maximum point. And this is shown by the graph on the right side, where a is less than 0, which means a negative number. Similar to the graph on the left side, the axis of symmetry passes through the maximum point. For the graph a is greater than 0, for example a equal to 1, when the value of a is larger than 1, the width of the graph decreases. Conversely, when the value of a is smaller than 1 and approaches 0, the width of the graph increases. Let's put this information in table form so that we can see it clearer. For the graph a is less than 0, for example a equal to -1, when the value of a is smaller than -1, the width of the graph decreases. Conversely, when the value of a increases from -1 and approaches 0, the width of the graph increases. If we combine these two tables together, we will obtain a number line that looks like this. Now let us look at the second case, where the value of b changes only. Change in the value of b only affects the position of vertex with respect to the y-axis. However, the shapes of the graph and the y-intercept are unchanged. When b is equal to 0, the vertex is on the y-axis. For the graph a is greater than 0, when b is greater than 0, the vertex is on the left side of the y-axis, and when b is less than 0, the vertex is on the right side of the y-axis. For the graph A is less than 0, when B is greater than 0, the vertex is on the right side of the y-axis. And when B is less than 0, the vertex is on the left side of the y-axis. And lastly, let's analyze the case where the value of C changes only. Change in value of C only affect the position of the graph either vertically upwards or vertically downwards. The shapes of the graph is unchanged. Let us look at some practical example. Example 2.4.1. The diagram below shows the graph of f of x is equal to negative x squared plus x plus 6, where a is equal to negative 1, b is equal to 1, and c is equal to 6. Sketch the graph of fx formed when the following values change. We are given the function fx is equal to negative x squared plus x plus 6. A is equal to negative 1, b is equal to 1, and c is equal to 6. Our a is a negative value, b is a positive value, and c is a positive value. We apply the knowledge that we learned just now. A is a negative value indicates that it is a crying curve. When a is less than 0 and b is more than 0, the vertex of the curve is at the right side. And c is a positive value, c is our y-intercept, hence the curve cuts the y-axis at 6. We also get extra information from the diagram, that is, our x-intercept are negative 2 and 3. The first one, the value of a changes to negative 3 and negative 1 over 4 respectively. When the value of a changes from negative 1 to negative 3, the width of the graph decreases, and the y-intercept does not change. Therefore, the graph should look like this. The curve still cuts the y-axis at 6. The vertex is still the same, but is getting narrower. When the value of a changes from negative 1 to negative 1 over 4, the width of the graph increases, and the y-intercept does not change. Hence, the graph should look like this. Next, let's analyze when the value of b changes to negative 1. When the value of b changes from 1 to negative 1, that is, from a positive value changed to a negative value, the vertex changed from the right side to the left side of the y-axis. For this case, it is like a mirror image where the reflection line is the y-axis. So the vertex becomes here and the curve looks like this. All points are changed except for the y-intercept. The shape of the graph does not change. The third case, when the value of c changes to negative 2. The original y-intercept is a 6, and now our y-intercept become -2. The whole graph will move 8 units downwards. The shape of the graph does not change. Make a generalization from the changes in the shape and the position of the graph obtained. Let's make a conclusion from the results we get. When the value of A changes, the shape of the graph will change because the width changes, but the y-intercept does not change. When the value of B changes, the shape of the graph does not change. However, all points are changed except for y-intercept. When the value of C changes, the shape of the graph does not change, but it will move vertically upward or downwards.